Okay, so in this video we will be talking about atomic block. But before we study about atomic block, we have to have a knowledge of shared variables. So first we'll talk about shared variables and then we'll move forward to atomic block. So let's start. So shared variables are used to build in-memory cache, meaning that whatever we store in a shared variable, it will be stored temporarily in a cache memory until we refresh the execution group on which my application is deployed, or if we start our application, or if we start our application flow, right? So the value which is stored in our shared variable will be gone if my execution group is reloaded or my application is stopped and then started, and if my application flow is stopped and started. Right, so I'll show you a practical example and you can picturize this point. So let's start. I have created a simple message flow, a MQ based message flow. MQ input node will be using a input queue so that this flow can be triggered. We have a output queue so that whatever information is coming out of compute node will be sent to this queue. Okay, so let's start. So I'm going to declare a shared variable, and in second point you can see that shared variables are declared using keyword shared. So, and these can be of any type, be it character, integer, row type, whatever it is. So I am going to declare a shared variable. It is always declared at schema level, right? So let me declare it as a cache table, then a keyword shared. Let me have it as a row type. Why I am taking it as a row type variable for this example? Because I'm going to load some values from the database, and whenever we want to load some values from database into something, that has to be a row type, because row is kind of uh, variable. Row type is kind of variable which can store a name value pair, or we can say that which can store a complete tree kind of a structure. So from my database the values are retrieved in the form of tree, so my row type variable can store those. If you don't know about row type variable, I recommend you to please read about it first and then come to this video. So I'm gonna set cache table which I have declared dot record, or dot result, or dot xyz, whatever I want to write. I can write it like this, right? This is the way I can use my row type variable. So I have created an array which can store values from the database. Let me use pass through. Under pass through I'll write a query: select star from schema name, which is system in my case, dot table name. Table name is routing table, right? So I am storing all the values from this routing table into my cache table, which is nothing but a row type of shared variable. See, this is my routing table. So all the values is stored in this table will be stored in this r- row type of shared variable. So Now the requirement is take values from the database and send those values to a queue. Simple. So in order to send those value to a queue in the form of XML, we have to write this line and copy all the values from row variable into this tree. Now let me put a check. If not exists my cache table variable, then do this. See, if nothing exists in my cache table, then load it with the database and use it to put the result on a queue. But else means there is something in my row type shared variable. There is already something in my row type shared variable, then this condition will be executed. In that case, we don't have to load the database. Simply send the information to output queue. And if now let me see, I am using a database here, right? So for that I have provided my DSN name, local DSN, which I have already created, and I have also associated my DSN with my integration node. So there is some configuration which we have to do. I'm not going to talk about those things in this video. We have to run some mqsi setdb parents command to associate that DSN which we have created to our broker, right? So I have already done those things. My main topic is shared variable. My topic is not connecting to a database here. So I have provided a DSN name here, and that's why I can use my database. Now let me launch the debugger and see how things are happening. Let me trigger my flow using my input queue. Flow is triggered. Let me move inside the compute node. See, I think I have not deployed my application. Let me deploy it. Now launch it. Trigger it. Move inside the compute node. Now see, my cache table is declared as a row variable. You can see here, but there is nothing inside it. So my if condition will be executed. Now if I execute this line, see, in my cache table dot result there are so many results which came from the database. In result we have queue manager, queue name, queue description, username, same thing, right? All the things are retrieved in multiple results. Now if I execute this line, then in my output route the information retrieved from the database out is saved. See, all the results are saved in output route.xml.data. and if I complete this flow, it is terminated. And if I browse my out.queue, which I have provided as an output queue, there are 4 messages because I have already executed. Let me navigate to latest message. See, this message came, right? The information which is retrieved from the database, so this was our requirement. Now we are going to see use of shared variable here. Now if I again execute this flow, the value which is stored, I mean I have loaded the whole database in my shared variable. So if I again execute this flow, then I don't have to load the database again because it will be already there in my shared variable. This is the concept of shared variable, right? I have stored something in it, and it will be there temporarily until I do something with execution group or the application flows, right? So let me execute it again. See, see, values are already there in my cache table, right? So this if condition will not be executed. Now my else condition is executed only. See, right? And whatever is there inside my cache table, it will be moved to the output queue. So the point to be noted is that my shared variable, which is having the database loaded inside it, is using, I mean, we are using it to send the information to output queue, and by using it we are enhancing our performance because we have to invoke the database only once, right? Now if I execute this flow third time, then again this will be skipped, this line will be skipped, and this will be executed. If I execute this flow fourth time again, only this line will be executed, right? And this line will be skipped, meaning that calling to database will be skipped, which can enhance our performance, right? So using shared variable is enhancing our performance. So let me terminate this flow. Again we can see that values will be loaded in my queue. Okay, so let me read it now. Let's terminate the debugger. Now if I do something with my execution group, if I this is my application, right? If I reload this execution group, or if I start this application, or if I start this message flow, or if I redeploy my application, in all of these cases the value stored in my shared variable will be gone. So let me show you one example out of these. Let me reload my execution group. mqsi reload test node ash hyphen e default. No, command is completed. So let me execute my flow again. See, see, there is nothing inside my cache table type of variable because I have reloaded my execution group, right? Now it will again load the data. So anyhow, it is enhancing my performance because I am skipping my calls to the database. Now, see, there is a problem. Now the problem is, suppose now I have loaded this database into my shared variable. Now my shared variable is containing all the information, same information. Now suppose tomorrow something has changed within the table. This in.q is changed. Suppose description is changed. From input queue to sample input queue. Let me commit the changes. See, sample input queue. But if I execute my shared variable, I mean the flow which is containing the shared variable, if I execute it again, as it is already loaded with the previous values, new values will not be reflected in it. See, directly else block will execute because it is previously loaded with some values, and in the result we have same old value. So we may have some these kind of cases, and we have to properly take care of these things, right? Whenever we are using shared variable, we have to take some proper precautions. So what can we do in that case? In that case, we have to load our shared variable again, right? So that it will start refresh. I mean, so that it will start fresh and it will load the values from the database again. But as I said that if we reload execution group or application flows, then the previous value will be gone and new value will be loaded. But this is not a good practice, right? On production server, you cannot go and reload your execution group directly, or go and start your application flows directly. On production servers, you cannot directly access your flows, right? So this is not a good practice. And another point is, in the same execution group, there are chances that there are 4 or 5 applications deployed. So during my execution group is reloaded, my those applications which are running in production uh, may get affected. So this is not a good practice at all. So what can we do to overcome this situation? We can create a flow. See, we can create a flow which contains MQ input, compute node. We can create a flow to refresh my cache. So I have a queue called cache refresh. And inside this compute node, we can write set cache table right? So let me revert the database to original values because I'm gonna replicate this scenario. Now, now this is my application flow now. Let me load my database with, load my shared variable with some values. Now my shared variable is having some values. Now I am changing the description to sample. Save it. Okay. Again execute my flow. My database is changed, but information which is being sent to queue is same old information. So now I have to refresh my flow. I have to refresh my shared variable so that it can load the values again. So whenever this flow is triggered, it will go inside this compute node and it will refresh my shared variable. So let me trigger this flow. See, I have triggered this, so my shared variable is cleared now. Now, now see. See, now it is having the updated result. Right. So this way we can achieve it. So we have to take a proper precaution. Again, there is a problem. The problem is, suppose my this flow is being executed and in between somebody refreshes my cache. Somebody executes this flow. Right. Suppose I'm using my shared variable to put the data into output route. Right. But before my this line is executed, somebody refreshes my cache variable. Somebody triggered this. Then problem may occur, right? Then nothing will come in this tree, in this output tree. Let's see that. Let me remove a debugger point. See. Now I am not going to execute this line, but before that I am going to refresh my cache. Now my cache is refreshed. If I go ahead, then see, this is blank, right? And if this is blank, then this is a problem. So what can we do to avoid this problem? We can use atomic block. Now this is the scenario where atomic block comes in picture. Atomic block ensures that only one thread is executed at one time, right? This is a technique to update the shared variable in a thread safe manner. Whatever I'm saying, we'll see that in a practical example so that you can picturize. So atomic block enables the threads to execute serially, one by one, right? If I am executing this flow first, then execution of this flow will be completed first, then only it will move towards this flow. If somebody will try to refresh my cache in between this flow is being executed, then he cannot do that. This thread has to wait until this completes. So this is the capability of a atomic block. So we'll see how can we do this. In order to do this, we have to encapsulate these statements under a block which is called atomic. We have to provide a label. Let's say it's x, then write begin atomic, then and x, right? Now we have to enclose the code inside this compute node within same atomic block, meaning this label should be same. We have used the label as x, right? Here also we have to use x, otherwise things won't work. If I use y, then things won't work. I have to use the same label so that it can recognize. Right. So let me replicate the scenario. Code is changed, so I have to redeploy it. And now let me replicate the scenario. So let's execute so that values inside my shared variables are loaded. Move inside the flow. Okay. Now my shared variable is loaded with the database. Right. Now again execute the flow. Move inside. Now before I execute this line, let me go and try to reload my cache. See, there is only one thread now. I am going to execute this flow so that another thread will come. Right. See, another thread came into picture. Now, if I try to move inside this flow and try to execute this, it won't happen. See, the moment I tried, this thread is gone. right? Now my previous thread is executed, right? Because it has to execute first. Another thread has to wait for it to complete, right? So let me move ahead. Now this thing is completed. Now after completion of previous thread, then it came inside the refresh flow to refresh my shared variable, right? So let me move ahead and see, this time I have everything in my message, right? Even if I tried to refresh my cache in between, but still it waited for previous thread to complete and I have my result in my output. So this is the use of atomic block, right? And this is very important concept. You know, after seeing this video, try to replicate the same scenario in your system and analyze thing what is happening, right? Try to uh, create different scenarios of this shared variable and atomic block so that you can know more about it. So this is very basic example. You can read more about the atomic block over the internet. Now, as now you have already know about the atomic block, so it will be easy for you to understand it when you read it on internet, right? So I recommend you to go on Google, try atomic block in ESQL. IBM website will open. Try to read it. Then you will easily understand what is written over there. Right. So this is very important concept. Please keep in mind. Thank you so much.